Hey guys, let's talk about how to work problems 9, 10, and 22 and achieve section 4.2. So these are some really good questions here. The first one has to do with an inverse cosine of x plus 8x. And of course, since it's an inverse cosine function, it's saying it's only defined for values of x between -1 and 1. And that should make sense because you know that the range of the cosine function is -1 to 1. So the domain of the inverse cosine has to be -1 to 1. But now, given that domain of the inverse cosine function, we're supposed to find all critical points. And the critical points, we remember, that's just where the derivative either fails to exist or is equal to 0. Now, over its domain, the inverse cosine of x and 8x will always exist. So the only critical points I will get is by setting it equal to 0. So you'll see down here, that's precisely what I did. I said, I'm going to take that inverse cosine of x plus 8x, and I'm going to take the derivative. Derivative of the inverse cosine of x is -1 over the square root of 1 minus x squared. Of course, the derivative of 8x is just 8. What I did at that point, in order to set it equal to 0 to find the critical points, I moved the fraction to the right-hand side, and obviously it became positive. Then I just multiplied by the square root on both sides to get rid of the fraction. So I have 8 times the root of 1 minus x squared is equal to 1. Then I went down and I said, okay, at that point, I needed to square both sides. I can't solve for x as long as it's inside of a square root. So the square of the left-hand side gave me 64 times the group 1 plus x squared to the first. Of course, the square of 1 is still 1. Now I divided by 64 on both sides. So I had 1 minus x squared is 1 over 64. And then what I did at that point is I moved the x squared to the right, the 1 over 64 to the left, and I had 1 minus 1 over 64 is equal to x squared. At that point, I started solving out. I took the square root of both sides. Square root of this is, of course, x. The other side had to be the positive or negative square root. And you'll see I went ahead and wrote 1 as 64 over 64. So I have the positive or negative root of 64 over 64 minus 1 over 64. That gave me x is equal to the positive negative root of 63 over 64. And then you needed to simplify that. So you can say, well, 63 is 9 times 7. We know 9 is a perfect square, so it's going to come out as a 3. And of course, the square root of 64 is 8. So the best final answers for those critical points would be the positive and negative 3 on the root of 7 over 8. Now, I'm pretty sure they're going to, it says give your answer in the form of a comma separated list. So they want them out individually. So I would say, okay, here if I'm trying to enter in these answers, and I'll have to use the keypad to help out, I would say, well, okay, I'm going to have the fraction, and I'll have -3 on the root of 7, so -3 on the root of 7. And that was divided by 8, and then comma. And my other one is just the positive version of that same fraction, so I'll say 3 on the root of 7 all over positive 8. Now just making sure that matched the answer I had here, positive -3 root of 7 over 8 should be great. Boom, I hit that, and it's saying, excellent, you solved it. Next question now, number 10. So number 10 gives us the function 4x cubed minus 11x squared plus 7x on the interval 0 to 4. We're supposed to be able to find the critical points. You know, the critical points are just where the function is either equal to 0 or where it fails to exist. The derivative of a polynomial will never fail to exist. So the only critical points we're going to get is by taking the derivative and setting it equal to 0. So you'll notice that's precisely what I did here. So I said, for number 10, here's my original function, 4x cubed minus 11x squared plus 7x. I took the derivative, 12x squared minus 22x plus 7. I instantly saw that that was not going to factor nicely. I didn't want to sit here and try to find factors of 84 that sum to get to negative 22. So instantly, I just went ahead and used the quadratic formula, kind of the chicken way out. You could have also solved it graphically. Uh, Although, actually, no, you could not have solved it graphically because it specifically wanted an exact form answer. So the reason I did not solve it graphically is because of that word right there, exact form. So that's why I chose to use the quadratic formula. It's the easiest way to get to exact answers. So I said negative b is positive 22 plus or minus the square root of b squared minus 4 times a times c, the 12 times the 7, all over 2 times a, 2 times 12. Of course, the denominator is 24. Your numerator is 22. And then when I did the 22 squared minus 4 times 12 times 7, I got a 148. Really quickly at that point, I knew I would have to simplify that down if I could. So I just went to my calculator and realized, hey, 148 has a factor of 4. It goes into it 37 times. So that square root of 4 is going to come out as a 2, and I can call the square root of 148 2 on the root of 37. Now I can see that this 24 can reduce down with both terms in the numerator by a factor of 2. So I divide every term in my expression by 2, and I would get 11 plus or minus the root of 37 over 12. That gives me two separate answers of course, 11 plus the root of 37 over 12 and 11 minus the root of 37 over 12. Now, that's what they're wanting for this first one when they say the exact answer format. So I'll go ahead and type that in here. I have the fraction, and my first one was 11 minus the root of 37 over 12. And then we would have comma, the second fraction is going to be our 11 plus the root of 37 over 12. And now I'll go ahead and check that answer. Well, actually, better not check that answer. It'll count it wrong because I need to do the whole thing. Now down here, it's wanting us to find the extreme values of the function. So that's going to be the extreme values of the function if they're wanting the y values of the function there. So I take the two values that I had as my critical points, and I went ahead and determined that both of those critical points were within the domain that was allowed in this function of 0 to 4. And then when I plugged them into the function, I just did this. So I said, for obviously, when x is 0, you can see that if you plug a 0 into that function, you're just getting a 0. You don't need a calculator for that. But now you probably do for the other ones. The first root that's a critical point, the 11 minus the root of 37 over 12, what I did for that is I just went in and I said, well, let's type that in as a fraction on the calculator, 11 minus the root of 37 over 12. It'll give you the decimal answer. But now we can take that and store it in for x. So I'll say, okay, I'm going to store that value in for x. Then I'll type in my function 4x to the third minus 11x squared plus 7x. And I can see that this function is just like I entered there, and it wanted me to round to 3 decimal places for the extreme value. So 1.297 when x is this value. When x is the next value, all I would do is scroll up to where I typed this in, and I could say, well, now all I have to do is change that minus to a plus, and then I will store this in for x, store x. And now I'll store this into that function. I'll arrow up to that function and say, tell me what that function is at this new value of x. That's where I got the negative 0.787. And then, of course, when x is 4, all you have to do is say 4 store x. Now make sure you type in your function or just arrow up to it, enter in on it, and I'll get the 108. So clearly in this problem, the maximum is at 108. The minimum is at negative 0.787. So now I'll minimize this and enter those values in. The minimum value was negative 0.787. And please do notice it said give answers to 3 decimal places. My maximum, 108. That should be good. And it is. For the next one here that I had a question on, I believe it was 22. Let me look at that one with you. So the question for 22, this one's actually going to be a little bit quicker than either the last two. Gives us a trig function and it's asking the maximum minimum value on the interval 0 to 2 pi. And it's wanting us to find this by comparing the critical points with the endpoints. Well, this is the extreme value theorem. The extreme values on any closed interval occurs at either the endpoints or the critical points within those points. So now the work that I did on this problem is right here. I took the function that they gave me, the 2 theta minus 4 sine theta. I took the derivative, 2 plus 4 cosine. Remember, derivative of sine is going to be cosine, and I can say, or derivative of sine, ooh, I've made a mistake there. Derivative of sine is not, it would be a negative cosine because that's a minus sign there. So I have the wrong answer there. I'll have to fix it here with you guys live. So what I've done wrong here is I said that the derivative of a negative sign is a positive cosine. No, 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 no. So because of that, it's going to change all of this. That was gorgeous work had that derivative been correct, but sadly that derivative was not correct. So let's go through and do the problem here live. Y prime here, derivative of 2 theta is certainly 2. But the derivative of sine is cosine. So the derivative of minus 4 sine is minus 4 cosine of theta. We still set that equal to 0 to find your critical point. And then you would say, well, okay, once I set that equal to 0 to find my critical point, I'll just say 2 is equal to 4 cosine theta. So 2 over 4 is equal to the cosine of theta. You said, well, then that just means the cosine of theta is 1/2. This problem is extremely similar to the one I worked out up here with the wrong derivative. Up here, I had to find out when the cosine of theta was a negative 1/2. Now I need to find out when the cosine of theta is a positive 1/2. Well, you know the cosine of theta is a positive 1/2 when the x component on the unit circle is a positive 1/2. That's going to occur at an angle of pi over 3, and it's going to occur at an angle of, this would be 2 pi, which is 6 pi over 3 minus pi over 3, 5 pi over 3. So that's my 2 values of theta that are going to be critical points in this problem. So pi over 3 and 5 pi over 3. Those are my 2 critical points. Now, just like I did up here with the wrong critical points, I need to do it with the correct critical points for this problem. So the extreme value theorem says that any maximum or minimum on a closed interval occurs at the endpoints or at any critical point within them. So we're going to have 0, the first endpoint, the 2 critical points, pi over 3 and 5 pi over 3. And then my last one being the 2 pi. So now I need to evaluate the original function at these x values to find what's the maximum, what's the minimum value. This first one, you don't even have to use the calculator for it because you know that the sine of 0 is 0, 2 times 0 is 0. So when you plug in a 0, you get a 0. If I plug in the pi over 3, 2 times pi over 3, obviously 2 pi over 3, then I would have minus 4 times the sine of pi over 3. The sine of pi over 3 is the square root of 3 over 2. When I go to 5 pi over 3, I would have 2 times 5 pi over 3 is 10 pi over 3. And then minus 4 times the sine of 5 pi over 3. And I know the sine at 5 pi over 3 would be the negative square root of 3 over 2. And then I can say for the last one here at 2 pi, well, you know that the sine of 2 pi is again 0 because it's the y value on the unit circle at that angle. But I would still have 2 times 2 pi is going to be 4 pi, then plus 0. So now I just need to, in order to determine which is the maximum minimum values, I'll simplify these out. This second one here is the same thing as 2 pi over 3. And then I would say minus 2 on the root of 3. Your next one is going to be 10 pi over 3. And it would be plus 2 on the root of 3. And I'll get some decimal approximations for those last three just so I can see which is my highest and which is my lowest value. So the 2 pi over 3 minus 2 on the root of 3, that's actually giving me a negative value. So it's negative 1.37 rounded to 3 decimal places. My next one here, the 10 pi over 3 plus 2 on the root of 3 is giving me 13.963, or 936, I should say. And then lastly, of course, 4 pi is actually less than that. So that's not going to be an extreme value, the 12.566. So we can see that our maximum is right here. Our minimum is here. Now, it's just a matter of, does the site want an exact or decimal approximation? I think you're always probably safer, especially when it doesn't specify, probably putting the exact answer. So I'm not 100% sure what they want on this problem because it does not specify whether they want exact or decimal approximations. Since it does not say rounding to 3 decimal places or anything like that, I would assume they want the exact answer. That's what I'm going to try. So my minimum value in this case, that was the 2 pi over 3 minus 2 on the root of 3. So I'll say, okay, I'll go down here, fraction, I have 2 pi over 3. And then that was minus 2 on the root of 3. And then my maximum was the 10 pi. So I'll again bring up the fraction. It was 10 pi over 3. And then plus 2 on the root of 3. And just to double check, that's the same as what I had here. You see, yep, you had the 2 pi over 3 minus 2 root of 3, 10 pi over 3 plus 2 root of 3. Those are your exact answers. And I'm assuming we want exact since it did not say how many decimal places accurate it wanted. So I'm assuming it wants the exact. This should be correct. We go up, check answer. Yes. So hopefully this helps you out with these 3 questions in this section 4.2. Please let me know if you have any other questions. I'm glad to help.